In this video, I'm going to be talking about something called cofunctions. So the question is, what is the relationship between the sine and cosine values of complementary angles in a right triangle? First of all, complementary angles means that the two angles, two or more angles sum to equal 90 degrees or pi over 2 radians if we're measuring our angles in radians. Okay, so let's say we have a right triangle. And I have angle T here. Let's say theta is here. And this is a right triangle. Now, we know that because this angle right here is 90 degrees, and the sum of all angles in a triangle add up to 180, what that means is theta plus t has to sum up to 90 degrees. So let's keep that over to the side here. And now let's find the sine of these. So sine of t, what is that equal to? And what is cosine of t? And then what is sine of theta? And what is cosine of theta? And I need to label a little bit more on this triangle. Let's label this side as x, this side as y, and this side as r here. Okay, so sine of t, sine is opposite over hypotenuse, so that'll be y over r. Sine of theta, opposite over hypotenuse, that's x over r. Cosine of t, that's the adjacent over the hypotenuse. And then cosine of theta is the adjacent, so y over r. So something to notice here is that these two are equal to each other, and these two are equal to each other. Okay, so in other words, I could say that sine of t is equal to cosine of theta. And what I'm going to do is I'm going to use this original relationship that I had up here to rewrite or to solve for theta. So I could say theta is equal to 90 degrees minus t. So I'm going to replace this theta with this right here. So rewriting that, I can say sine of t is equal to cosine of 90 degrees minus t. So that is the cofunction relationship. So if I have sine of some angle, that is equal to cosine of 90 degrees minus that angle. And so that is what's I can write right here. Okay. And then we just need to remember which of the angles are cofunctions with each other. Sine and cosine are cofunctions. So I can rewrite, or I can write sine 90 degrees minus t as equal to cosine of t. Cosecant and secant are cofunctions of each other. So cosecant of t is equal to secant of 90 degrees minus t. Secant of t is equal to cosecant of 90 degrees minus t. And then tangent and cotangent are cofunctions of each other. So this is cotangent of 90 minus t, and this is tangent of 90 degrees minus t. All right, so this is how the cofunction relationships work, and we'll see how this is useful here in a moment. One other thing to note is that 90 degrees here can be replaced by pi over 2 in each of these 6 equations if we're working if our angle is in radians. Okay, so let's look at a couple quick examples of this, and I'll keep those here as a reference. So it says, if sine of t is equal to 5/12, find cosine of pi over 2 minus t. Now that's the same thing as 90 degrees there, if we want to think about that in degrees. Well, what we notice is that sine of t, this right here is the cofunction. So cosine of pi over 2 minus t is equal to sine of t. Well, we know what sine of t is equal to. It's 5/12. So that means this is also equal to 5/12. So cosine of pi over 2 minus t is equal to 5/12. And that's it. If we want to see this visually, if I have a right triangle, and let's say angle T is down here. Well, if sine is 5/12, sine is opposite over hypotenuse. By the Pythagorean theorem, I could solve for this missing side. And so this angle T down here, I don't know what that measurement is, but what I do know is that this angle is equal to 90 degrees minus T, because both of those together have to add up to 90. So if angle T is, let's say it's 30 degrees, this angle up here is 90 minus 30. It's 60. There's 60 degrees left over. And so then if I wanted to find cosine of 90 degrees minus T, I do the adjacent, which is 5, over hypotenuse, which is 12. So that's why those are equal to each other. Okay, and then let's do this last example here. It says if cosecant is 30 degrees, if cosecant of 30 degrees is equal to 12, find secant of 60. Now, one thing we will often want to do in our trigonometry sections is that it's not always easy to work with cosecant or secant, but it is a lot easier to work with sine of that. So instead of cosecant of 30 degrees, I'm going to change this to sine of 30 degrees. And what we can hopefully remember is that cosecant and sine are reciprocals. So instead of using 2 over 1, I'm going to write this as 1 over 2. So what this is saying is sine of 30 degrees is equal to 1/2. And sine is always the opposite over hypotenuse. Okay, so that's just kind of the beginning info that we're given for a reference. Secant of 60 degrees. Well, secant is the reciprocal of cosine. So let's see where sine of 30 degrees, what that gets for us. Now, one way to do this is if I draw a right triangle and I put 30 degrees down here. Well, I know that sine is opposite over hypotenuse, so I could use the Pythagorean theorem, find this missing side down here, and then I could go that route. The other option is, well, notice that 30 degrees and 60 degrees those add up to 90. Those are cofunctions. So that is 60 degrees up here. So if I wanted to find secant of 60 degrees, what I could do is, I don't know what that is. But if I can find cosine of 60 degrees, then I can take the reciprocal, and that'll give me secant of 60 degrees. So what is cosine of 60 degrees? Well, cosine of 60 is equal to sine of 30. Okay, if you don't see that, well, I know that sine of 30 degrees, that's my angle, that's going to be equal to cosine of 90 minus 30. Just using those cofunction relationships. So I know that cosine of 60 is equal to sine of 30. If sine of 30 is equal to 1/2, that means cosine of 60 is also equal to 1/2. That's all good and fine and dandy, but I don't actually care about cosine of 60. I really want secant of 60. So I just take the reciprocal of what we had down here, and it's going to be 2 over 1, or just 2. So that one's a little more complicated. We're kind of putting everything together here. And that's how we're going to do it. And also, I just want to mention, drawing a diagram or a triangle of this is often quite helpful, because if we didn't know how to draw on this or how to pick this up using the cofunction identities or these cofunction equations up here, this triangle that we drew, that could have gotten us there as well.